Top 1. The Antikythera mechanism. The year is 65 before the Common Era. A Roman cargo ship is cutting through the Aegean Sea somewhere between Crete and the Greek mainland. When it goes down, it takes its cargo with it: amphoras of wine, bronze statues, glassware, jewelry, and one other thing. A lump of corroding bronze about the size of a hardcover book, packed with gears so small and so precisely cut that the world will not build anything like them again for 1,400 years. The ship sinks, and the secret sinks with it. There it stays on the sea floor near the island of Antikythera for 2,000 years. In 1901, Greek sponge divers working the wreck begin hauling up fragments of corroded bronze. Nobody knows what they are looking at. The lump gets cataloged, numbered, and set on a shelf in Athens, where it sits for over 50 years. Then in 1951, a historian named Derek de Sola Price takes a closer look. What he finds rewrites everything. Inside the corrosion are at least 37 interlocking bronze gears, not decorative, but functional gears, a differential gear assembly, an epicyclic pin and slot mechanism, and inscribed on the interior plates in Koine Greek, a user manual explaining what each dial does. This is the Antikythera mechanism, and it is, without question, the most technologically sophisticated object ever recovered from the ancient world. The device measures 34 cm tall, 18 cm wide, and 9 cm deep. Turn the hand crank, and the front face displays the position of the sun and moon in the zodiac. The back face runs two spiral dials. One tracks the 19-year Metonic calendar cycle, the interlocking rhythm of solar and lunar years that allows you to predict when eclipses will fall. The other counts down to the 4-year Olympic Games cycle. There is a subsidiary dial that tracks the Saros sequence, an 18-year, 11-day eclipse prediction system accurate to within 1 or 2 hours. In 2006, the Antikythera Mechanism Research Project used high-resolution X-ray tomography to read the internal text in full and confirmed that the device also tracked all 5 planets known to antiquity. The University College London team's 2021 reconstruction proposed that the front panel alone originally held 30 additional components, showing a unified model of the entire known cosmos. The Saros dial's accuracy is the part that keeps engineers up at night. Predicting eclipse sequences requires understanding that the moon travels its orbit at irregular speeds, faster when close to Earth, slower when far. This is what we now call the elliptical orbit, a concept formally described by Johannes Kepler in 1609. The Antikythera mechanism models this irregularity mechanically through a pin and slot gear assembly that physically accelerates and decelerates the lunar display to match the moon's actual movement. That gear was supposedly reinvented by Flemish engineer Simon Stevin around 1600. The mechanism sitting in the Athens Museum has one built around 100 before the Common Era. Isotopic analysis of the bronze alloy published in the Almagest Journal in 2017 confirms the metal almost certainly originated in the Corinthian region, consistent with a manufacturing date somewhere between 150 and 60 before the Common Era. Here is where the mainstream explanation steps in, and it is a fair one. Greek engineers were extraordinary. Hero of Alexandria built programmable mechanical theaters. Archimedes designed siege engines that terrified Roman commanders. The scholar Cicero, writing around 60 before the Common Era, described a device made by Archimedes that reproduced the motions of the sun, moon, and 5 planets. So the Antikythera mechanism was not built by magic. It was built by people operating at the apex of a known tradition of Hellenistic mechanical ingenuity, working from centuries of accumulated astronomical observation. But here's the problem with that explanation. Every major technological tradition leaves stepping stones, simpler prototypes, failed experiments, workshop debris. The trail leading up to the Antikythera mechanism is essentially blank. It appears fully formed with no identified ancestors. And then, after it sinks, the tradition it represents vanishes so completely that 14 centuries pass before Europe builds anything mechanically comparable in the form of the first astronomical clocks of medieval cathedral towers. One ship, one mechanism, 0 successors. Some researchers ask whether this device was produced at a center of knowledge, possibly the great library network of Ptolemaic Alexandria, or the astronomical school at Rhodes, where a body of mathematical and mechanical understanding existed that was never committed to papyrus, or was committed and then burned. If one merchant vessel happened to be carrying one of these instruments, how many existed, and what happened to the civilization of craftsmen who could build them? We may never know. What we do know is that a lump of corroded bronze pulled from the Aegean seafloor contains gears that the modern world took 14 centuries to reinvent. Whatever tradition produced it, that tradition died with the ship. Top 2, Puma Punku. From a machine built to track the cosmos, we travel now to the Bolivian Andes, to a plateau at nearly 13,000 feet above sea level, where someone left behind a different kind of impossibility. One that doesn't fit in a museum case because the smallest pieces weigh more than a modern cargo truck. Stand at Puma Punku, and the first thing you notice is the silence. The Bolivian altiplano stretches away in every direction, cold, flat, and immense. Scattered across the ground in front of you, as if thrown there by a furious god, are the ruins. Enormous H-shaped stone blocks, each one a near-perfect mirror of the next. Right angles so sharp you could cut yourself on them. Flat surfaces so smooth they reflect the pale Andean light. Through the middle of some blocks, internal channels are drilled with a precision that a modern machinist would recognize immediately and then struggle to explain. This is Puma Punku, part of the broader Tiwanaku archaeological complex. Dated by radiocarbon analysis to approximately 536 to 600 of the Common Era, it sits at 3,840 meters above sea level and was built by a culture with no confirmed writing system, no iron tools, and no wheel. Those are the facts that the mainstream timeline asks you to hold in your head while you look at what was apparently built without any of them. The H-shaped andesite blocks are the centerpiece of the mystery. There are dozens of them, and they are geometrically identical to within roughly 2 millimeters across all surviving examples. 2 millimeters, that is the tolerance of a manufactured part, not a hand-carved stone. The andesite itself registers between 6 and 7 on the Mohs hardness scale. Bronze, the hardest metal available to the Tiwanaku culture, registers at 3. You cannot carve a harder material with a softer one to sub-millimeter precision. You simply cannot. The physics do not allow it. The largest single block on the site, known as the plataforma, measures 7.81 meters long, 5.17 meters wide, and just over 1 meter thick, with an estimated weight of 131 metric tons. It was transported from a quarry approximately 10 kilometers away. The red sandstone blocks on the site were sourced from a quarry 90 kilometers distant across Lake Titicaca, requiring water transport on reed boats capable of handling multi-ton cargo. Every block arrived, every block was placed, and no one left behind a single tool capable of producing what we see on their surfaces. The experimental archaeology record here is unusually honest. Jean-Pierre Protzen of the University of California, Berkeley, published a detailed study in the Journal of the Society of Architectural Historians in 1985 examining Inca stonework techniques across the Indian tradition. His method was direct. He tried to reproduce the stonework himself using period-accurate tools. He achieved reasonable results on flat surfaces through patient stone-on-stone battering, but he could not reproduce the three-dimensional polygonal jointing geometry that characterizes the most sophisticated blocks. Repeatedly lowering a 131-ton stone to check its fit against 6 irregular neighboring faces, adjusting and lifting again, is not an iterative process any human team could manage. It is an engineering calculation performed before the stone moves. There is also the matter of the metal clamps. At Puma Punku, certain blocks were joined using eye-shaped metal connectors cast molten directly into pre-cut T-shaped grooves in the stone surface. The same technique, not similar but identical, appears at Sacsayhuaman in Peru and at ancient sites in Egypt and Lebanon. The connectors were not brought to the site preformed. The metal was smelted and poured on location into pre-cut slots, meaning someone transported portable smelting equipment to a plateau at nearly 13,000 feet and used it to pour precision connectors into stone grooves. No smelting facility has been found at Puma Punku. The mainstream explanation is that the Tiwanaku culture was a sophisticated Andean state with a highly organized labor force. Expert stonemasons who accumulated craft knowledge over centuries and the religious motivation to deploy enormous human resources on monumental construction. With enough skilled workers, enough time, and enough accumulated technique, the argument goes, results like Pumapunku are achievable. The polygonal interlocking style, far from being mysterious, is actually excellent engineering. It distributes seismic stress across irregular surfaces rather than concentrating it at regular joints, which is why Andean builders adopted it. But accumulated craft knowledge does not explain the absence of tool marks. Every stonework tradition in history, Egyptian, Greek, Roman, medieval European, leaves identifiable marks, chisel striations, grinding scratches, percussion patterns. Pumapunku's andesite surfaces are anomalously clean, and no experimental team has successfully replicated a single H-block using period-accurate methods at full scale. Some researchers, including French material scientist Joseph Davidovits, have proposed that the blocks were not carved at all but cast, poured as a reconstituted stone slurry into wooden molds, which would explain both the geometric precision and the absence of tool marks. If the Tiwanaku builders had discovered how to chemically reconstitute andesite, that would represent a materials science not independently achieved in the modern world until the 20th century. We do not know if that is what happened. What we know is that what we can see at Pumapunku does not match what we know how to build. Top 3. The Lycurgus Cup. From a plateau in the Bolivian Andes, we travel now to the heart of the Roman Empire, not to its legions or its roads, but to a single glass cup sitting quietly in the British Museum that contains a secret Rome apparently discovered and then completely forgot. The Lycurgus Cup. Pick up the Lycurgus Cup in a dark room and hold it to the light. What you see will make you check the label twice. The glass is green, jade-toned and translucent, carved with figures of King Lycurgus of Thrace, being swallowed by grapevines in a scene of divine punishment. Turn a candle behind it, and the cup transforms. The green vanishes. The glass goes blood red, a deep wine-dark crimson glowing from within, as if something alive has been trapped inside the silica. This is not a trick of the display case. It is not a modern coating. The Romans built this color shift into the glass itself at a scale 50 times smaller than a human red blood cell. The physical principle behind it was not theorized by science until 1908. The cup dates to the 4th century of the Common Era, and its earlier history is unrecorded. It surfaced in the 19th century as part of the Rothschild collection before the British Museum acquired it in 1958. For years, the color shift phenomenon was noted but unexplained. Then in 1990, a team of researchers from the British Museum, Ian Freestone, Nigel Meeks, Margaret Sachs, and Catherine Higgett, put a fragment of the glass under an electron microscope. What they found had no business being there. Suspended uniformly throughout the glass matrix were nanoparticles of a gold-silver alloy averaging 50 nanometers in diameter. 50 nanometers. That is 1/1000th the width of a human hair. The alloy composition was not random. It ran approximately 70% silver and 30% gold. It was a deliberate formulation, and the particles were not clustered or aggregated. They were distributed with a consistency that produces a uniform optical effect across the entire vessel. At that scale, metallic particles interact with incoming light through a quantum electromagnetic effect called surface plasmon resonance. Essentially, the electrons in the nanoparticles oscillate at frequencies that absorb and scatter different wavelengths of light depending on whether the light is coming from in front of or behind the glass. The result is the color shift from green to red. Gustav Mie described the mathematics of this scattering phenomenon in 1908. The Romans were producing it in the 300s. The implications compound when you consider what the cup's principle can actually do. In 2013, researchers at the University of Illinois at Urbana-Champaign published a study demonstrating that a Lycurgus geometry nanoparticle array is sensitive enough to detect changes in the refractive index of fluids surrounding the particles. In plain language, the basic architecture of the Lycurgus cup, a nanoparticle suspension in glass that responds optically to what surrounds it, is the functional precursor to modern optical biosensors used to detect pathogens in liquid samples. A Roman wine cup accidentally invented the structural principle of a category of 21st century medical diagnostic technology. The cage work of the cup itself, the outer decorative net of carved figures attached to the inner vessel by only three glass bridges, belongs to a tradition of Roman cage cups called diatrata, which represents arguably the highest technical achievement of ancient glasswork, and which was also entirely lost after the fall of Rome. Only one other ancient glass object with confirmed dichroic nanoparticle properties has been identified, a fragment from a Roman site in West Hill in Somerset, England, suggesting that at least two Roman workshops knew the technique. No Roman text names either workshop, no glassworker's manual describes the process, no guild record lists the formula. The mainstream explanation is that Roman glassworkers were empirical experimenters who discovered dichroic effects by accident, adding metal filings or colloidal solutions to glass batches, observing the results over generations, and refining by trial and error what they could not explain in theoretical terms. The sophisticated outcome does not require conscious nanotechnology theory, only patient craft iteration across many decades of workshop experimentation. But here is what that explanation cannot account for. Producing nanoparticles at a consistent 50 nanometer diameter, uniformly suspended in molten glass without aggregating into larger clusters that destroy the optical effect, at a specific controlled alloy ratio, is not an empirical accident any craftsman stumbles into. Researchers at institutions studying nanoscale materials today have found the precise temperature and chemistry window required to suspend nanoparticles this way to be unusually narrow. Random experimentation produces random outcomes. The Lycurgus cup is not random, it is controlled. Someone understood what they were doing in functional terms, even if they could not name the physics. Some historians of materials science propose that the knowledge chain runs back to Hellenistic Alexandria, where alchemical traditions describe the reduction of metal salts into fine particulate suspensions. Colloidal gold preparation as a craft technology, not a theoretical exercise. If that tradition existed and was transmitted to Roman workshops through the networks of Alexandrian scientific culture, the Lycurgus cup may be the sole surviving physical proof. When Alexandria burned and its scholars scattered, the recipe apparently burned with it. Top 4, the Delhi Iron Pillar. From Rome's impossible glass, we move east now to a country that left its metallurgical achievement standing in the open air of Delhi, where it has been quietly defying the laws of corrosion for 1,600 years, the Delhi Iron Pillar. It is not dramatic when you first see it. No colossal scale, no hidden chamber, no inscriptions that require translation by secret societies. It is simply a dark iron column rising 7 meters from a courtyard in the Qutb complex in Merali, on the southern edge of Delhi, surrounded by medieval Islamic architecture that was itself built from the rubble of earlier temples. The pillar predates everything around it by roughly 1,000 years. A Sanskrit inscription near its base identifies it as a memorial to a king named Chandra, which historians have correlated with the Gupta emperor Chandragupta II, who reigned from around 375 to 415 of the Common Era. The pillar celebrates his military victories across the Bactrian frontier. None of that is the interesting part. The interesting part is that this column is made of iron. It has been standing in the open air of northern India through monsoon humidity and punishing summer heat, through 1,600 years of the kind of wet-dry cycling that destroys iron, and it has almost no rust. A thin, dark surface patina, yes, but no structural corrosion, no flaking, no pitting. The iron beneath the surface is essentially intact. Modern metallurgical science did not understand why until 2002, when R. Balasubramaniam of the Indian Institute of Technology Kanpur published a landmark analysis in the journal Current Science. What Balasubramaniam found, confirmed through X-ray diffraction, was that the pillar's surface had developed a self-assembled protective layer of a compound called misawite, a form of crystalline iron hydrogen phosphate approximately 1/20th of a millimeter thick. This layer forms in the wet-dry cycles of the Indian climate, is self-repairing when damaged, and prevents further oxidation indefinitely. The Western iron and steel industry did not develop corrosion-resistant iron alloys until the early 20th century. The Gupta metallurgists had apparently achieved the equivalent result 100 years earlier. The key was the iron's composition. Analysis found the pillar to be approximately 98% pure wrought iron with a phosphorus content of roughly 0.1 to 0.25%, unusually high by the standards of any other ancient ironworking tradition. That specific phosphorus range is precisely what enables Massaoit formation. Virtually no slag inclusions were found in the material, meaning the Gupta smelting and forge welding process was of extraordinary cleanliness compared to contemporaneous Roman or Chinese iron production, which typically showed 5 to 10% slag content. The construction method itself is staggering to consider. The pillar was not cast in a single pour. It was built by forge welding an estimated 120,000 individual pieces of iron together, heated to approximately 1,000 degrees Celsius, hammered into adhesion, then shaped and ground to the final profile. To heat a multi-ton iron mass uniformly to forge welding temperature requires a bellows and furnace system capable of sustained high-temperature combustion across the entire cross-section of the object. No such forge site from the Gupta period has been definitively identified. The mainstream explanation credits the accumulated empirical expertise of Indian metalworkers who had developed the world's most advanced ironwork tradition over centuries, producing the legendary Wootz steel that medieval traders carried across continents as the sharpest blade material known to the ancient world. The Delhi pillar, in this view, is simply the apex of that tradition. Craftsmen who had worked with the high-phosphorus iron ores specific to the Indian subcontinent long enough to learn through experience which smelting conditions produce the most durable results. But the standard explanation runs into a specific difficulty. The Gupta period was one of the most literate and intellectually productive eras in Indian history. Mathematicians of the Gupta court gave the world the concept of zero. Astronomers produced heliocentric models of the solar system. The Arthashastra, a Mauryan-era treatise, documents metallurgical processes in detail. And yet no Gupta document, no craft manual, no court record describes the process for building a rust-proof iron pillar. The formula, whatever it was entirely oral. When the craftsmen died, it died with them. Some researchers ask whether the Gupta metallurgists were working from an even older inherited knowledge base, one reaching back through the Mauryan Empire toward a tradition of ironwork whose origins we have not fully mapped. Balasubramaniam himself has proposed that understanding Massaoit formation could transform modern anti-corrosion coating technology, meaning a discovery made empirically in 4th century India is now actively guiding 21st century materials science. We borrowed the answer from people who apparently found it without knowing the question. Top 5. Göbekli Tepe's encoded comet. From India's iron that refuses to decay, we travel now to a hilltop in southeastern Turkey, to a site so old and so precisely constructed that when researchers finally decoded what was carved into its stones, they proposed that the builders were not recording mythology. They were recording an astronomical date, a date for the end of the world before ours. 12,000 years ago, before the first city, before the first known writing system, before the invention of the wheel, someone organized enough people to quarry limestone blocks weighing up to 10 tons, haul them across a hilltop in southeastern Anatolia, and arrange them into precise circular enclosures anchored by pairs of T-shaped pillars up to 6 meters tall. The mainstream timeline of human prehistory says this should not be possible. At 10,000 before the Common Era, humanity consisted of scattered hunter-gatherer bands. No agriculture, no surplus, no state apparatus to mobilize labor. And yet Göbekli Tepe exists, sitting on a ridge 15 kilometers northeast of the modern Turkish city of Şanlıurfa. Radiocarbon dated to at least 9,600 before the Common Era, which makes it 6,000 years older than Stonehenge and more than 7,000 years older than the Great Pyramid. The site was identified in a 1963 survey, but dismissed as a medieval cemetery. German archaeologist Klaus Schmidt recognized its true significance in 1994 and excavated it until his death in 2014. What he found beneath the surface had been deliberately buried. Every completed enclosure was intentionally backfilled under tons of limestone rubble, preserving it perfectly and raising a question nobody has adequately answered. Why would you bury your own temple? The unfinished pillar still lying in the bedrock quarry 100 meters from the main site gives a partial picture of the construction method. It measures approximately 7 meters long, was being shaped directly in the bedrock, and was presumably going to be undercut and freed once complete. It weighs an estimated 50 tons. No ropes or sledge systems capable of moving it have been found near the site. No habitation layers, no cooking hearths, no storage pits, and no sleeping areas have been identified within the complex, meaning Göbekli Tepe was not a settlement. It was a destination. People traveled to it, built on it, and then at some point buried it completely and walked away. In 2017, Martin Sweatman and Dimitrios Tsikritsis of the University of Edinburgh published a peer-reviewed paper in Mediterranean Archaeology and Archaeometry proposing something that reframes the entire site. They argued that the animal carvings on the most elaborate pillar in the complex, Pillar 43, are not decorative. They are a star map. Specific animals correspond to specific constellations in a system using the same zoomorphic star naming conventions documented in other ancient astronomical traditions. The vulture as Sagittarius, the scorpion as Scorpius. When the configuration of carved animals is overlaid onto the ancient night sky, the astronomical positions encode a specific date. That date is approximately 10,150 before the Common Era. That date matters because of what a large multi-institutional study published in the Journal of Geology in 2018 identified at that precise moment in geological time. 24 researchers across 12 countries, analyzing sites on 4 continents, found a consistent layer of impact proxies at approximately 10,135 before the Common Era. Nanodiamonds, platinum group elements, shocked quartz, and microscopic spherules consistent with a cosmic impact event of continental scale. This is the Younger Dryas boundary event, a proposed comet or asteroid strike that some researchers believe triggered the 1-to-100-year cold period known as the Younger Dryas, and may have devastated human populations across multiple continents. Sweatman's interpretation, if correct, means that Göbekli Tepe was not built by primitive hunter-gatherers ascending toward civilization. It was built by people who already knew what a civilization-ending catastrophe looked like because they had survived one. People who encoded the date of that catastrophe in animal carvings on limestone pillars deliberately as a memorial or a warning, and then buried the entire record under tons of rubble so it would outlast them. The mainstream archaeological position is that the animal carvings are totemic and mythological, not astronomical, and that the date correlation Sweatman identifies may be coincidental. Identifying constellations in ancient carvings involves interpretive choices that are not uniquely determined by the images themselves, and correlation with the YDB date does not prove intent. But the deliberate backfilling of the entire site has no satisfying explanation under any conventional religious abandonment model. Cultures abandon temples. Cultures sometimes demolish temples. No culture has been documented systematically burying a complete ritual complex under precisely placed tons of rubble as if sealing a vault. Geophysical surveys suggest only 5% of Göbekli Tepe has been excavated. Whatever is in the remaining 95%, it has been waiting 12,000 years for someone to ask why it was hidden. Top 6. Sacsayhuaman's Living Walls. From a hilltop in Turkey, where someone may have encoded the end of one world in stone, we descend now to the Peruvian Andes, where another civilization built walls that have outlasted every earthquake the mountains could throw at them. Sacsayhuaman's Living Walls. In 1950, a major earthquake struck Cusco, Peru. Modern concrete and stone buildings across the city cracked, collapsed, and fell. When the dust cleared, the walls of Sacsayhuaman, built by the Inca roughly 500 years earlier, without a single drop of mortar, without concrete, without steel rebar, showed essentially no structural damage. The earthquake had destroyed the colonial city that had grown up in Sacsayhuaman's shadow. The ancient walls simply absorbed the energy and stood. That survival is not an accident of good fortune. It is the result of an engineering principle so sophisticated that structural engineers studying the walls in the late 20th century found it had been deliberately built into the design, a design that, according to the standard timeline, was produced by a civilization with no written engineering manual, no university-trained architects, and no formal mathematics beyond what could be encoded in knotted chords. Sacsayhuaman sits on a ridge 2 kilometers north of Cusco at an elevation of 3,701 meters. Its three main terrace walls are constructed from irregularly shaped polygonal limestone blocks, the largest of which stands approximately 8.5 meters tall, 5 meters wide, and is estimated to weigh 125 tons. There are roughly 3,000 multi-ton blocks in the main walls. They are fitted together without mortar in three-dimensional interlocking joints, each block touching its neighbors on multiple irregular faces simultaneously. The precision of the fitting was described by Spanish chronicler Pedro Chiesa de Leon in 1553, and his description has been confirmed by every modern engineer who has examined the walls. A standard sheet of paper cannot be inserted into the joints. Jean-Pierre Pratzen of UC Berkeley spent years attempting to understand Inca stonework through experimental archaeology, publishing his findings in 1985. His conclusion was that the Inca shaped stones primarily through battering, repeatedly striking them with harder stones to remove material. This method can produce flat surfaces, but it cannot easily produce the complex three-dimensional polygonal joint geometry seen at Sacsayhuaman, which requires that each block fit its neighbors on 6 or more irregular faces simultaneously with no gaps. To lower a 125-ton stone onto its neighbors, check the fit on every face, lift it again, adjust and repeat is not a process. It is an engineering impossibility without pre-calculated geometry. A 1998 analysis by structural engineers John Earls and Gary Urton identified why the walls survive earthquakes that destroy buildings beside them. The zigzag pattern of the three terrace walls, which appears purely aesthetic from a distance, functions as a seismic energy dissipation system. Under oscillatory seismic loading, the irregular polygonal joints allow individual stones to shift microscopically and redistribute stress laterally across the wall's face, rather than concentrating it at fixed points. The wall moves slightly as a whole and then restores itself. Modern seismic engineering achieves controlled structural flexibility through calculated joint design. The Inca achieved the same result without apparently a single written calculation. The Spanish colonial authorities who dismantled parts of Sacsayhuaman in the 16th century to build Cusco's cathedral provide an inadvertent proof of the construction's difficulty. They successfully removed the smaller blocks for reuse, but the blocks above approximately 20 tons they left in place. No Spanish equipment available in the 1500s could move them. The same blocks remain in place today. The mainstream explanation is entirely coherent as far as it goes. The Inca operated the mita, a labor tax system that mobilized tens of thousands of workers annually for state projects, and Andean builders had accumulated centuries of craft knowledge in polygonal stone construction. The earthquake resistance is understood as a practical empirical discovery made over generations of building in one of the world's most seismically active regions. But the absence of a pre-calculation method for three-dimensional joint geometry has never been resolved. And the same eye-shaped metal connectors poured molten into pre-cut stone grooves that appear at Pumapunku also appear here at Sacsayhuaman, and also independently, separated by the Atlantic Ocean, at ancient sites in Egypt and Lebanon. 3 separate civilizations, no confirmed contact, identical specialized connector technique. The mainstream answer is parallel invention, but some researchers look at that specific technical coincidence and ask whether parallel invention is actually the most economical explanation or simply the most comfortable one. Top 7 Mohenjo-Daro's urban sanitation. From earthquake-proof walls in Peru, we travel to the Indus Valley to a city abandoned 4,000 years ago that achieved something no ancient civilization before or since attempted at comparable scale. A system of public sanitation that served every single resident, not just the elite. Close your eyes and imagine London in 1800, Europe's largest city, the capital of an empire that controls a quarter of the world's surface. Raw sewage flows in the streets, the Thames is an open sewer, and cholera epidemics kill tens of thousands. The city will not build a functional underground drainage system for another 65 years, not until 1865 when engineer Joseph Bazalgette's underground sewer network finally begins to control the death toll. Now open your eyes and walk through a city built 4,600 years earlier in the Indus Valley of what is now Pakistan. Every house has a toilet. Every toilet drains through a covered brick channel. Every channel connects to a municipal sewer network running beneath the streets with inspection ports at regular intervals, so blockages can be cleared. This is Mohenjo-Daro, and the gap between what it achieved and when it achieved it is one of the most quietly staggering facts in the entire history of human civilization. Mohenjo-Daro was unknown to the modern world until 1922, when archaeologist R.D. Banerjee identified the site during a survey led by John Marshall of the Archaeological Survey of India. What systematic excavation revealed was not a primitive settlement. It was a planned city on a gridded street layout with an estimated population of 35,000 to 40,000 people, constructed from standardized fired brick with two distinct drainage systems, one for household gray water and a separate system for solid waste, indicating that the Indus engineers understood the sanitary principle of separating waste streams. That principle was not formally articulated in Western public health until the 19th century. The brick standardization alone is remarkable. Fired bricks across the entire Indus Valley civilization, sites spanning approximately 1.5 million square kilometers from modern Afghanistan to Gujarat, maintain a consistent dimension ratio of 1.2.4 in height, width, and length, with the most common size running approximately 7 mas tina, 7 means. This standardization across a civilization larger than ancient Egypt and Mesopotamia combined implies a centrally administered manufacturing standard and a distribution network of extraordinary organizational reach. Someone somewhere decided on the dimensions, and everyone across 1.5 million square kilometers used them. The Great Bath at Mohenjo-Daro, excavated by John Marshall in 1926, measures 12 meters long, 7 meters wide, and 2.4 meters deep. It was constructed from fired brick set in gypsum mortar, waterproofed with a bitumen layer, and backed by a second layer of brick. A multi-layer waterproofing system that Marshall himself noted rivals the structural sophistication of purpose-built Roman bathing infrastructure constructed 2,000 years later. Over 700 wells have been identified at Mohenjo-Daro, roughly one well per 50 residents, giving a per capita water access ratio that European cities did not match until the industrial era. The mainstream explanation for all of this is straightforward and defensible. The Indus Valley civilization was a sophisticated Bronze Age urban culture that developed its engineering organically from earlier Neolithic water management traditions in the region. The hygienic emphasis likely reflects cultural values around ritual purity that are documented in later Vedic religious texts. With sufficient population density, organizational capacity, and cultural motivation, the sanitation infrastructure is achievable through accumulated craft expertise over generations. But here is what that explanation does not address. Every other Bronze Age state-level society of comparable sophistication, Mesopotamia, Egypt, the Minoans, the Shang dynasty, built impressive monumental architecture for their elites and left their ordinary residents to manage their own waste however they could. Mohenjo-Daro's sanitation system served every house. Not the palace, not the temple complex, every house. That is not a reflection of engineering capacity. It is a reflection of a civic ideology about the rights of ordinary people that has no parallel in the ancient world and that was not systematically articulated in Western political thought until the Enlightenment. There is also the script. The Indus Valley civilization produced an estimated 4,000 inscribed seals in a writing system that remains completely undeciphered despite decades of effort by linguists worldwide. A 2009 statistical analysis by Rajesh Rao of the University of Washington, published in Science, confirmed that the script has the mathematical properties of a structured language, not a simple labeling system. Without the script, we cannot know how the city was administered, who decided on the brick ratio, who built the sewers, or why they built them for everyone. The answers to all of those questions are sitting in those 4,000 seals in a language nobody alive can read. Top 8. The Dendera Reliefs. From a city that built for its ordinary people, we travel now to a temple in Egypt, where the priest built something on the walls that Egyptologists and electrical engineers have been quietly disagreeing about for 50 years. The Dendera Reliefs. Deep inside the Hathor Temple at Dendera, 60 kilometers north of Luxor, there are a series of subterranean crypts not accessible on the standard tourist route. The ceilings are low, the air is dry, and on the walls carved into limestone in the Ptolemaic period, roughly 50 before the Common Era, are a series of images that have generated more disagreement per square centimeter than almost any other ancient carvings in Egypt. What you see in the most analyzed panels are large, elongated objects, bulb-shaped at one end, tapering toward a base structure. Inside each bulb is a serpent running the length of the object, touching the narrow end at one tip. The base from which each object appears to emerge is shaped as a jed pillar, the Egyptian symbol associated with Osiris and stability. Human figures stand beside and beneath the objects in postures that could be interpreted as worshipful or operational, depending entirely on which interpretive framework you bring to the room. The Egyptological interpretation has been consistent and well argued. The elongated shapes are lotus buds or cosmic eggs. The serpent inside is Harsamtus, the primordial serpent deity associated with divine power and protection. The Djed pillar base is a standard religious symbol with centuries of documented use. The whole composition is a theological scene representing the emergence of divine creative force from the primal source. Egyptologist Eric Hornung, in his 1999 work on Egyptian esoteric traditions, acknowledged the electrical interpretation as the most widely circulated alternative reading, but dismissed it as unnecessary given the established mythological vocabulary. That alternative interpretation originated with Austrian electrical engineer Walter Garn in the 1960s. Garn looked at the Dendera carvings and saw something different. He saw the geometric profile of a Crookes tube, a glass vacuum tube with an internal electrode from which a filament discharge runs when current is applied, the direct ancestor of the modern light bulb. In his reading, the elongated bulb shape is a glass envelope, the serpent is the discharge filament, and the Djed pillar base is an insulating support of the type used in high-voltage electrical apparatus. He constructed a functional vacuum tube using the geometry of the Dendera relief as a schematic and reportedly produced a faint electrical glow. The physical detail that neither interpretation fully resolves is the state of the crypts themselves. Enclosed subterranean spaces used in antiquity for any purpose requiring human presence required light. Every enclosed ancient space where torch or oil lamp illumination was used, from the burial chambers of the Valley of the Kings to the service corridors of Roman temples, shows traces of carbon deposition on ceilings and upper walls. The Dendera crypts are consistently reported to be soot-free. If oil lamps or torches lit the space, the physical evidence of that should be present. It is not. The Ptolemaic period when these carvings were made placed the Dendra temple within the intellectual orbit of Alexandria, where scholars simultaneously explored static electricity, pneumatics, and steam power. Hero of Alexandria built programmable mechanical theaters in this era. The library and museum complex of Ptolemaic Alexandria represented the most concentrated scientific community in the ancient world. The idea that Alexandrian-era scholar-priests had developed practical applications of electrical or electrochemical phenomena for use in specific ritual contexts and encoded the technology in religious visual language as a form of trade secrecy is not impossible. It is simply undocumented. Some researchers have also pointed to the inscriptions accompanying the Dendera crypt carvings, which include terms appearing only once in the entire surviving corpus of Egyptian hieroglyphic writing. Hapax legomena, single occurrence words whose meaning cannot be triangulated from other uses. If the scenes depicted were standard religious compositions, the language describing them should be standard religious language. The presence of unique, untranslatable terminology in these specific panels suggests the scenes may be depicting something that required vocabulary not needed anywhere else in the religious record. We may never know what lit the Dendera crypts. What we do know is that the question has not been answered. These are 10 objects, 10 artifacts pulled from the ground, the sea, or the walls of ancient temples. When you lay them side by side, a gear computer from Greece, cut stone precision from Bolivia, nanotechnology in Roman glass, rust-proof iron from India, a comet memorial encoded in stone in Turkey, earthquake-resistant walls in Peru, a citywide sewer system in Pakistan, possibly electrical schematics in Egypt, an unnamed instrument from the Roman frontier, and an aerodynamic model from an Egyptian tomb. A pattern emerges that the individual mainstream explanations, each of them reasonable in isolation, have difficulty accounting for collectively. The mainstream view is that each of these represents the apex of its own local tradition of accumulated empirical expertise. Skilled craftsmen, patient iteration, motivated labor, convergent problem solving. Human ingenuity, given time and need, can reach extraordinary conclusions independently in different parts of the world. That is a coherent framework. It has a lot of evidence behind it, and it is probably right about many things. But the pattern that appears across all 10 of these artifacts is not just sophistication, it is sophistication followed by total disappearance. The Antikythera tradition vanishes for 400 years. Rome's nanotechnology dies with the craftsmen who made it. The Gupta iron formula is never written down. Mohenjo-Daro's administrative knowledge dies with an undeciphered script. The Roman dodecahedra lose their name and function in a single generation. The Saqqara bird sits in a box for 71 years before anyone recognizes it for what it is. In every case, the knowledge was not passed on. It was lost completely, as if the tradition were severed rather than faded. That pattern, sophisticated knowledge appearing, functioning, and then vanishing without a written successor, suggests something that the standard linear model of human progress has difficulty explaining. Progress in the standard model accumulates. It does not disappear without leaving traces. But these 10 artifacts are the traces. They are what remains after something much larger disappeared. Maybe the most honest position is this. We have assumed, without quite realizing it, that we are the most sophisticated version of humanity that has ever existed. These objects suggest that assumption deserves more scrutiny than it typically receives. Not because they prove an alternative, they do not, but because they demonstrate physically that the gap between what ancient people could do and what we credit them with knowing was sometimes much smaller than the history books suggest. Most people walk through museums, read the label card, and accept the silence between the object and the explanation. You did not do that. You stayed for all 10. That means you understand that the distance between what we can prove and what we can see with our own eyes is where the real history is buried. If these 10 artifacts have changed the way you look at the primitive past, then join us as we continue to dig deeper. We are unearthing the history that time tried to bury and the secrets that were never meant to be forgotten. If you believe the past holds more than we've been told, please subscribe to the channel and like this video to support our investigation. The next treasure of human ingenuity is waiting to be rediscovered. Let's uncover the truth together.